Hello, welcome to everyone in this video. This is our lecture number 9 of electronics theoretical part, and this is the lecture 1 or part 1 for field effect transistor FET. You all know that in this lecture series we want to discuss about the electronics for different part. This is the syllabus for University of Calcutta 4th semester BSc honors. This part, that is the circuit and network, we cover in lecture 1, and then in the after that lecture we discuss about the semiconductor diode and application, where PN junction, rectifier diode, etc. We already discussed the principle of this LED photodiode solar cell, already covered, and BJT, bipolar junction transistor, and its biasing also covered. So up to that one we cover up the previous lecture up to lecture number 8. So if you want to watch the previous lecture, you can go through the description box, link are given there. In this lecture we want to discuss this field effect transistor FET. Okay, total portion we want to discuss in this lecture, and the upcoming lecture will be cover up this regulated power supply, amplifier, feedback amplifier, that is op amp, multivibrator and oscillator. This will be covered up in upcoming lectures. So let's start. And if you want to watch the previous different field related theoretical and some problem solution, you can go to the description box. Different playlist link are given there. So let's start today's discussion. First of all, we know about the basic difference between the FET, that is the field effect transistor, and BJT, that is the bipolar junction transistor. Actually, in field effect transistor, this output current is depend on the applied field. We will be learn about the basic principle, operation of basic principle in the upcoming slide. But at this moment, you know that is the FET, that is the field effect transistor. That means its output is depend on the field, electric field. Whereas in BJT, this output depend on the junction. That's why this is called the bipolar junction transistor, and this is called field effect transistor. The name is denoted is operational principle. Okay, FET is known as unipolar and the BJT is known as bipolar. Why? Because in FET the current flow due to this the majority carrier, that is the one type of carrier flow the current through this channel or substrate, whereas in the BJT the current flow due to both the carrier, that is the minority carrier and the majority carrier. That's why the BJT is known as the bipolar junction transistor, whereas FET known as the unipolar junction transistor. Okay, and in FET the only majority carrier carries, and BJT both majority and minority carrier carries. FET is simply fabricated and occupies less space in IC integrated circuit compared to BJT. So FET is the more cheapest, more small size, or it is take the small space, and its fabrication also the simplify compared to the BJT. And FET have a high input in resistance compared to BJT, where we need to the high input resistance. Then we use the FET, and FET also less noise compared to BJT, and FET makes excellent signal chopper. That means which amount of signal we need to chop, you can use this FET to chop the signal. Okay, so this is the basic difference between the FET and BJT, and the advantage of FET over the BJT. Okay, type of FET. There is mainly two types of FET are available, that is JFET and the MOSFET or MISFET. JFET means junction field effect transistor. Their junction is affected by this field, that is called JFET. And the another type is insulated gate field effect transistor or metal insulator semiconductor field effect transistor, that is the MISFET. That means where the junction is like that, the metal, then insulator, and the semiconductor. So that I call this is MES. One type of MESFET is MOSFET, that is the basic basically used in MOSFET. Sorry, metal oxide semiconductor. Actually this oxide behaves as a insulator. So this MISFET MOSFET is nothing but a one type of MISFET. Metal, this insulator will be oxide, and this is the semiconductor. This will be the structure of MOSFET. This is the MISFET. Okay, I think clear. MOSFET is one type of MISFET. So let's discuss about the detailed uh, operation on a JFET. You can see this is the structure of JFET. This is the N channel. This is the N type semiconductor bar. This big rectangular bar is the N type semiconductor bar, in which two plates these are conducting plates and that also conducting plate. Sorry. These two are the two conducting plate. This terminal known as source and this is drain depending upon the voltage apply within this. These two are symmetry. You just change the voltage apply, this name will be changed, that is source, that will be drain. Okay. So this is a bar of n-type semiconductor. This is called channel and these two sides are conducting plate connecting with the conducting plate. And this region, if this is a rectangular, then upper and lower, otherwise if it's cylindrical, then round wise it will take a highly doped opposite side. This is n type, so there will be doping of the p plus. Okay, trivalent doping in the high density. Plus means in the high concentration. When the doping concentration is high, then denoted by plus symbol. Okay, so this region is p plus, this is n channel and these two are electrode and there is a junction also. Sorry, there is a junction are permitted here. So when these are connecting like that, you can see this is connected in the negative side, this p plus is connected in negative side and this also is positive, so n is high and p is less, so this is in reverse bias. Okay, so you know in reverse bias the depletion region will be increases. Since the density concentration is p side is high, that's why the width of this depletion region in p side is less compared to this n channel n side. So the depletion width of n channel is higher compared to the p side, because this density concentration of p side is high, that's why this n depletion region spread over this channel. Okay, now if we apply this voltage, so here you can see this current flow from that region to that region and electron flow through that one to that one. You can see here this is the n type channel. Since this is a n type channel, the majority carrier is electron. The majority carrier is electron and electron flow from that region to that region. So this is like a source of electron and this is the drain of electron. Okay, the source is nothing but the terminal where the majority carriers enter the bar known as the source. You can see the connection is like that, so electron from that region to that region. So this is a source, so because the electron flow, that is the majority carrier of this bar, that is the electron flow from that region to that region. Okay, and the gate, this is gate because this reverse bias produce the depletion region, and depletion region, between this depletion region this current is flow, and if we increase this voltage, the gate the depletion region will be increased, and after a certain time this will be just touch. Okay, so these two depletion region behaves like a gate, that's why this terminal is known as the gate. So three terminals: source, drain and gate, and this is the channel, but the bar is known as the channel. I think clear about this schematic diagram. There are two type of JFET: N channel JFET and P channel JFET. This channel will be N channel and P channel. You can see this for N channel. This is the N channel. This is the N channel. You can see here that in this N channel, when this is a reverse bias, when this is a forward bias, the current flow from P to N, so the gate to inwards. That's why in case of in the N channel, the gate to inward is the direction of the arrow. In the opposite sense, in the when this is a P channel, this will be N plus. Then the current flow from the channel to this gate, then the current flow will be from channel to this gate. That's why the arrow is from this channel to the towards the gate. So this is the n channel circuit symbol of the n channel JFET, and this is the circuit symbol of the p channel JFET. Okay. So for n channel JFET, the channel will be n type, and for p channel JFET, channel will be p type, and gate will be the opposite. When this channel is n type, the gate will be p plus, that is the highly doping concentration with the whole means trivalent. That's why this is denoted as the p plus type. And this when this is a p channel, then the gate will be n plus, that is it's doped with the pentavalent. Okay, so these are the two types of JFET, and they are a circuit symbol like that. And I think you clear about this arrow from gate to channel and this is the channel to gate. For n channel, the current will be from p to n in the forward bias. That's why this gate is p and the channel is n. That's why this is arrow from gate to channel, and this is the from channel to gate. Within a JFET, the resistance controlled by this gate voltage. At this resistance, you can see this depletion region's resistance will be increased. So that's why input resistance is large, and this is a voltage control resistor, because you can control the resistance of this path. In this path, this is electron flow or the current flow along that path, and the current flow of this region is actually controlled by this resistance, and this resistance actually controlled by this voltage. That's why this is called the voltage control resistor. That means its resistance can be controlled by the external voltage. Clear? So if you wants to know about what is the pinch off and why this is not uniform, the depletion region is not uniform, and why what is known about the pinch off. You can think that is the this is a p plus, this region is p plus, so that's why this depletion region is not expand to this high density region, it's expand in low density, low concentration region. Okay, and this channel will be this depletion region will be distributed like that. This distribution region distributed like that. Why this distribution is like that, you can think about like here. Suppose this VG voltage is some voltage like that, that is the 2 volt, this voltage, this is negative voltage, and here you apply the 5 volt. So this 5 volt means there is 0, there is 5, so there is 1 2 3 4 so on, and this is a minus 2 in the negative voltage, so this is a minus 2. So what is the difference between the potential between that point to that, from A to this G? This potential difference will be 0, and this minus 2 difference will be 2. For that region, this is 2 and minus 2 difference will be 4. For that region, this is 5, this is minus 2 difference will be 7. So you can see, if you increase from the source to, if you go from source to drain, the potential difference between these two regions will be increased. That means the reverse bias voltage increase, and with increasing the reverse bias voltage, the width of the depletion region also increase. That's why if you go from source to drain, the width of the depletion region will be increased. The width of the depletion region will be increased when you go from source to drain. Clear? Why this depletion region is not uniform? Because the potential difference at every point will change, because there is a potential applied throughout the source and the drain. Okay, and this change due to this increasing of the potential, and the potential difference between gate to that point also increases. That's why this region will be increases when we come from source to drain. Okay, now, this things is what is pinch off. With increasing this voltage at a certain time, these two are nearly to touch, just touch. This voltage actually known as the pinch off voltage. When we increase the gate voltage, think about here. This voltage is constant, and now if we increase this gate voltage, so the voltage in difference also increases. At a certain time, if these two are connected to just like touches to each other, just touches to each other, This is known as pinch up, and the corresponding voltage is known as pinch up voltage. After that, if you increase this voltage, this is not touching crossing each other, because these are two same type of charges are occupied here, so these are repels to each other. So this region increases and this current will be saturated. So clear about the pinch off. Now if you want to find out the expression of the pinch off, that is the expression of the pinch off voltage or thickness of the depletion region, you can find from this uh, derivation. You can see this is total with diameter is 2a, and this is the depletion region. At a certain distance, the depletion region width is w of x. So this will be taken as 2b, which is function of x. So from the Poisson's ratio, you can see this will be the expression. And you know that is the density of this anion is very much greater than, because this is a P plus, that's the anion density is very high compared to the donor density. That's why width of this P side is very low than the width of the N side, which I will actually discuss in previous one. This is written in mathematical form. So the from the Poisson's ratio, this will be the equation, and if you integrating, you will be get these things, and if you put this boundary condition, you will be get this value of C1. Putting this value C1, integrating again, you finally got this relation. Okay, after getting this relation, you know at the uh, when y equals to w of x with that is the width of this depletion region, these potentials are equal, v of x equals to v of y, that is the applied voltage actually finded here. So if you put this relation, finally you will get this width of this depletion region, and at the pinch of voltage, this width of the depletion region will be a. Width of the depletion region will be a, because at the pinch of this touches to each other, nearly touches to each other, so this will be a. So if you put this value of a in this region, you can easily find out the value of pinch of voltage, that is E n d by 2 epsilon a square. So this is the pinch of voltage. If you want to find out the potential at the distance x, you can use this. The width of the depletion region is a minus b of x, so b of x equals to like that. B of x equals to like that. Okay, so this is the value of this pinch of voltage. Now comes into the actual operation occur in a n type n channel JFET. Look at this diagram. Actually, this is a n type JFET. There is no diagram. Sorry, there is no diagram. Okay, no problem. This is MOSFET. Sorry, there is no diagram available in this region. The diagram is this one. Okay, memorize this diagram and just taking this account this language. Okay. Actually, in this region, you know, this one in the reverse bias. In this region, this diagram says this is a reverse bias. So, if you increase this voltage, the current will be increases in the reverse region, and you can see here. Sorry. If you increases the drain voltage, the current will be linearly increases, and after a certain voltage, this will be saturated because these are in the reverse bias, saturated. After increasing a certain value of voltage, this will be in a breakdown region. So in this region you can see when this voltage is applied voltage is increased, this is a constant voltage. So there is a depletion region increases. So if you increase this value, the depletion will also increase. After a certain value, this will be saturated, Pinchoff condition. After saturation, if you increase this value, the current will be saturated. After after a large value of this is baked out, and there is huge amount of current is flow out. Huge amount of current is flow through this. This is a breakdown region. So this all about the reverse bias things like that. Okay. This is the current notation, direction of current, positive and negative like that. Or drain current, gate current, source current, and their voltage like that. Okay. The drain current, saturation current is known as the saturation current, and the corresponding voltage, drain voltage, and the saturation is known as the saturation voltage. As a reverse gate bias, increase the both ID saturation and luminance. The graph represent this drain current to gate voltage like that. This is the VGS. This voltage is VGS. Okay. So this is the voltage current graph like that. Expression of saturation drain current. The saturation drain current will be like that. IDS equal to IDSS 1 minus VGS by VP whole square. Okay. So if you take this derivative, you will be get this one, and this is the value. So the transfer characteristics at VGS interact with the VGS axis as VPS is after a method of determine VP. So using this value, you will be get this value of VP, that is the Pinchoff voltage. This is the method by which we can find out the Pinchoff voltage. Why JFET is the less noise? Actually, JFET are useful for low noise amplifier. The noise is less because the majority carrier participate in the device operation. In this JFET operation, you know that is the that is the majority carriers used to operate this one. So that's why this is the less noise use. A BJT current control device, while if FET voltage control device, you know in the BJT the current actually define the forward bias, reverse bias, and here the voltage control the action. Now comes into the MOSFET. Full form of MOSFET is metal oxide semiconductor. That is the metal like aluminum, like gold, aluminum, silver, like metal. This is the oxide, this silicon oxide layer, and after that this is a silicon. These three are layer. Okay. Now, if you apply this negative voltage at gate, so this plus induced, and this due to plus, this is a minus, and for minus this is a plus. Actually, this is not a plus. This hole is induced here. This is a N substrate, and the minority carrier hole is induced here. Now, if you supply a voltage difference between that to one, plus and minus, this hole is follow the current path. This induced charge actually flow this current. After a certain voltage is induced, if holes are attracted below this. So after a certain voltage, these holes are attracted here. This voltage is known as the threshold voltage. Okay, below this voltage, there is hole are not accumulated. After a certain voltage, these are accumulated. This is called threshold voltage. After that, this current will be increases. So after threshold voltage, this will be increases like that. This is the circuit symbol. Okay. Now the depletion MOSFET. Depletion MOSFET means there is a additional layer are added here. So if this is a P substrate, this are the N channel will be enhanced here. Now if you apply the same thing, negative voltage, so this is positive, this is negative induction, and this negative, the hole is attracted here, so this channel is reduced here. Okay, so the current will be reduced. So if you increasing the VGS in the opposite direction, the current will be reduced. So this is the depletion and this is the enhance. Okay, this is reduced. So the transfer characteristics ID versus VGS will be like that. VGS positive, this is enhance, and this is negative, this is depletion. Okay, so the total mechanism write down here. You just write it down. You can easily find out the operation mechanism. I think clear. This is the question. You just try to solve this question. I think you can do this. If there is any problem to solve this, you must comment in the comment box. Okay. So this is all about me. This is my contact detail. You can connect me with the Telegram channel. This is my online platform, and this is my YouTube channel details. Go to this channel. You will get different related video. Like this session. If you learn something from this session, share this video to your friends. Either he or she also get a benefit from this video. Subscribe this channel if you new in this channel. And those already subscribed, thanks for subscribing. Press the bell icon to get notification of upcoming video. So take care. We'll meet you in the next video as soon as possible. Thank you.